Should I start?
Yes,
Is
yes,
that
Saurav.
okay?
Yes,
Okay.
yes, yeah, please go ahead. Yeah.
Okay.
Or
Okay.
maybe let me ask if anybody so needs a break, maybe short break. We are already bit late. If not, doesn't look like. Okay, maybe Saurav. You can start, I think.
Okay. Okay. So today we will learn basically how to write a analysis task in this physics framework with some minimal effort. And basically at the end of the this lecture, we will have some skeleton of this analysis task, which we will further use tomorrow and day after tomorrow. And there we will implement it further event selection and track selection criteria and other things. So this analysis task that we are basically used for our analysis in Alice, it's has the form of classes. So I think most of you are aware of the classes in the C++, although I will just give you a brief introduction of the classes before going to the analysis task section. So our analysis task that we are going to be used is basically written in a C++ class. And what is class? This class is basically a object which contains both the variable and function. And these variables or function are basically known as the members of the class. For example, here in this box, here I just put a simple example for the class. Here, how we can define a class? You can define a class by just writing class, then the name of the class, then start with a curly bracket and end with another curly bracket. And any variables and function inside this class are basically known as the members. Now, these members basically have three types. One is public, another is private, and another is protected. For the moment, let's just consider on public and private. So what is this private? What is this public member? So this public members means if you initialize your variable or the method, that basically the function under this public members, then you can directly access those member out of in your macro out of this class. But if you define your variable in the private member section, then you cannot directly access this member. You need to access this through a method or through the other members of this class. For example, here I define two different kind of members. One is private. In private members, we have variable called width and height. So this width and height cannot be accessed directly. And in the public member, we have two function. One is the set values, and then there is the area. So this area is basically return your width and height. So it basically it basically use the member from this private, and it gives you the width into height. Now you can see that this set value is basically is a member function, and it's have a type void. So you can define this member function out of this class like this way, where this member in order to call this member function, you need to where this member function can directly access the members of the private like width and height. For example, here this member function of two argument x and y, which is basically equal to the width and height. So this member function here in this public member function, it basically access this width and height. Now let's see in a simple program how can we create a object using this class and use the function that is defined inside the class. For example, let's define a object called rect, which is from this rectangle class. So how can we define it? We just need to write the class name rectangle and then the object name, that's the rect. Then you can directly access the public member by just using this dot. So if you use this rec dot set values, then you can directly access this set values where you can put your input values like 3 and 4, which will basically goes here. Then you can directly also access the another public member, that is the area, by using the rect.area. Now the more details about this class you can find in this tutorial. So I will not go in the more details of the class. I will just give you some brief hints that we can that is basically will be useful in order to understand our analysis task in a physics framework. Now in class we have another function that is called the constructor. So this constructor is very useful in order to initialize the member values. For example, in this macro, if we do this rec.area before calling this rec.set values, it will give some arbitrary values because our va- we did not initialize our values. So in order to initialize these values, we basically used a function that called the constructor. So what is the constructors? So this constructor will automatically called whenever a new object of this class is created. Means if you define a constructor, then if you call a object, for example, rectangle rect, then if when you call a object, it will automatically call the constructor of that object and allowing you to initialize the member variables or the allocated storage. Now, how can we define this constructor? This constructor function is declared just like the regular member function. For example, here the regular member function is a set value in this example. So you can directly define this constructor like similar way as the set values. But you need to keep remember that this constructor do not have any kind of type. Means it cannot be any type like void, int, or double. And you need to put the name same as the class name. For example, in the right hand side here I show a simple example of this constructor. So this is the rectangle class, and here I have defined a constructor that is the rectangle which have the same name as the class. But here you can see that instead of means in contrast of the set value, there is no particular type. Means I did not define any type, because in constructor we do not assign it any type. Then you can in the similar way as the previous example, you can define this constructor like this way. And for example, when you use this now let's see how this constructor will work. So in your main program, if you define a object called rect from this rectangle class, you can directly initialize these values here by putting just in it is in this argument. So what happens then if you call the rect.area, then it will basically gives you the 3 into 4 12, because it will take the initial value that you used in this constructor. So with this some basic idea, now let's look another important properties of the class. So that important properties of the class is the inheritance. That means you can always derive a class from any other class. For example, here I just for example, if this C polygon is a class, then you can also derive another two class, for example C rectangle and C triangle, from this class. In this case, the C polygon will be known as the base class, and the C rectangle and C triangle will be known as the derived class. So how can we derive a class from the base class? For example, here I have defined a base class, that is the polygon, which have a private member width and height. Now you can define a derived class from this polygon class. For example, let's say derived class is rectangle. You can define this like this way. uh, Rectangle, then you need to put the name of the your derived class, that is the rectangle. Then you need to put a colon, and then the base class, which is the polygon here. Now in this rectangle class, here you can see there are the members, public members, that is the rectangle and gate area, and you can directly access this public member. But you can see that this public member is basically access the members of this base class, which is width and the height. You can see here in this return. Similarly, you can also derive a class triangle from this base class polygon where you used the member of from this base class, that is the height and width. Now with this basic idea, let's see first how this analysis frameworks works in Alice. So in the left side, in this workflow, you can see the analysis framework is basically start with a macro that, that is basically a steering macro that known as run analysis.c, where we basically initialize and configure and launch our analysis. This macro will call your AddTask macro, which basically make a copy of your analysis task and submit. If you want to submit a job in the grid, it will basically submit it in the grid. Then this add task macro then calls your analysis task here. So this analysis task basically have three different function. That's at the user create you can see here user create output objects, user execution, and terminate. So this three function has three different role. For less example, this first function, that is the user create output object. Here we basically initialize our output object. For example, in your output root file, if you want to get some histogram or tree or profile, you need to initialize those output objects, output root objects in this function, that is the user create output objects. Then we call our user execution. So this is user execution is basically the main program where we write our analysis algorithm, means whatever analysis you want to do, like invariant mass of selection of some particle, if you want to do some calculation of some pt, phi, eta, all these things you need to write in this user execute function. So this user execute function, it basically a event loop that will execute your algorithm for each event. Then it will test, then it will check if there is any more event left or not. If there is any more event, that it will again do the same analysis, perform the same analysis algorithm until there is no event is left. And when there is no event is left, it will basically go to the terminate, which will basically finish your analysis task. And at the end, you will get your output result, that is the analysis results.root. So here this set of uh, program in the left side is basically known as the analysis manager, with which you just manage your analysis. Means from here you select in where you in which data set you want to run in, you want to run it locally or in grid, all those things. And you need to if you need to copy your analysis task and it make a copy and then submit it in the grid. So all this thing is known basically is the analysis manager. And the right part of the section of this and this right part where is basically the function that is basically used in your analysis task is basically your physics analysis part. So we will first start with this physics analysis part here, then we'll gradually goes to the add task macro and the run analysis macro. Now, as I mentioned earlier, that the one of the important properties of the class, that is the inheritance, means you can derive the class from any other class. So this thing is basically used in the Alice analysis framework. So in the Alice analysis framework, we all the analysis tasks are derived from this class, that is the Ali analysis task AC. This AC stands for the single event. Now, this what is the advantage? So the advantage is that it provides us with a common framework in which one can do the analysis. And inside of this LE analysis task AC class, you have this six. You have these six members. So you have the two constructor here, then one destructor. Then you have the user create output object where you basically initialize your histogram tree or profile, whatever output you want to get. And in the user execute, you write your analysis code, means your algorithm analysis algorithm. And in terminate, you will basically finish your code. So we will use a fixed format of writing our class. That is basically we will first write our header file in which we contains the function prototypes. That means where we write the prototypes of these five members. And if you want to add more, you can add more. Then we will go to the .cxs file, where we will basically implemented our analysis code inside this user execute object, and define the output object like histogram and tree in this user create output object. Then we will go to the addTask.c macro, where which basically creates an instance or copy of your class and configure it and submit it in the grid. For the more information, you can go to this link. So let's start with the header file, that is the ali analysis mytask.h. So the header file first start with this three basic command line. So these two will be go at the beginning of your task, and at the end you will have this command. So what is this three line means? These three lines is basically form a include guard, which is sometimes called the macro guard or the header guard. This basically avoid of any duplication of your include directive. For example, in this in between these lines, if you include your header file, like if you have some header file which you need in your analysis, if you include it, then those header then that header file will not be duplicate further in the analysis chain. And this duplication sometimes causes a problem in your analysis. In avoid to do that, we use this include card. Now let's go to the first line, how we can define our analysis task from this base class analysis task AC. So as I shown in my beginning slide how to define it, we just use the same formalism. We basically put the give the name of our class, that is the analysis task my task, and basically derived it from this base class, that is the analysis task AC. And in this curly bracket we will further define all the other members of our analysis task. And here you can see I have also included the ali analysis task.ac.h, which is basically the header file of this ali analysis task single event class. Now let's start with the public members. So in the public members, as I showed earlier, that we will have these six different function, that is the two constructor, one destructor, one object for the initialization, one for execution, and for terminate. So we need to write it in the similar way. So here you can see we have defined the two constructor here, one destructor. For the destructor, you always need to remember that you need to put this tilde sign. So what is this destructor? So I've already mentioned about the constructor. So this constructor is basically used to initialize your members, and this destructor is basically when you delete delete any created object. In order to release the memory, you need to add this destructor. Then you will have this three important function where we will basically work and write our analysis tasks, that are the user create output object, user execute, and terminate. And as I already mentioned, that in this user create output object we will define our histogram or root file, histogram or tree or profile. And this is our execute, we will basically do our analysis, we will write our analysis code. That means some loop over track, or getting some variable from the track information and all those things. And in the terminate, it will basically end. Now there is another line you need to add in your header file, that is the class def. So I will not go to the details what is this class def. So I just for your information, this class def is a C processor macro that is always used when your class is derived from some T object. For example, here this LA analysis task is a object. So when you derive your class from this LA analysis task C, we need to define this class def. And in the class def, you can see there is two argument. One argument is basically the name of your class, that is the LA analysis task my task. and the another argument is some number. So this number is basically, for example, this 0 is basically disable this input output of your class. So therefore we start from the number 1. So for practical purpose, you do not need to change this number, you can do it with 1. But sometimes you also may need to change this number, depend if you changes your class. For example, this so basically this is related to the root steamer. So what is root steamer? So root steamer, so okay, I will go to this root steamer next, in the next slide. Okay, here I will talk you about the what is the root steamer. So in the analysis task, so just for the moment, let's see, we have seen that we have defined the public members here. Now let's define the private member which will be used in your analysis. Those are basically your input and output object. For example, we will going to use the AOD data. So we defined a pointer of this LEAOD event named as FAOD. Then we will store our output in a list. Therefore, we defined a T list and named it as F output list. And we defined a histogram. Basically, in this analysis, we will show how to fill a histogram of some variable like PT. So here I defined a histogram of F hist PT of T using a pointer. Now all these output and input variable that is defined under this private member. Now here you can see when I write some command like input event, output event, or dummy histogram, here you can see I have put another particular symbol, that is basically the double slash and a colon. So what is this? So is there any question? I think there is a raise hand.
Hello, sir.
Yeah, yeah.
I am Hirok.
Yes. Yeah,
Can you go to slide number 13? This is a
yeah,
previous slide.
yeah.
Yes. Uh, in the array analysis task, my task, there is a space between the star name, and in the virtual void line, the option underscore T star space option. Is there any difference between the space uh, where you write a star?
Here you are saying
Yes, yes,
option T star option.
yes. There is a
No, the
star space option, and in the array analysis task, my task, there is a character space star name.
no, it will not affect. Means you can put the star with this option. It will not affect.
Okay, okay. Thank you.
Hello, sir.
Yeah,
I am Bhagirathi Sahu.
yeah.
Sir, my question is, how can we declare separate files for class? If you have 3 to 4 member function, then how can we declare separate file for class?
I didn't get your question.
Uh,
Separate files means
Separate header.
you want to define separate header file for what? For one class, or
Yeah, not separate header file. If we perform 3 to 4 more tasks in one class, then we need to declare a separate file for each task.
so you are saying that you will do the derive class from, means you will derive 3 different classes from 3 different other base classes.
No, sir, I
Means
am
for
not very clear. Add some in some program, I don't do that program, and the problem is that you have to means concern course instructors said that you have to put separate head. I think separate file for each task. So I did
separate
not get.
files. Separate files mean what? Separate header file, or means whatever class that you are going to use in your derived class, you need to put corresponding header file in this include. You are talking about that or something else? I didn't get your point.
Okay, sir. I will clear it in last one at the last of classes. Just
Okay.
checking.
Okay. Okay. So as I mentioning that you can see a particular sign here that is a double slash colon. So this is basically related to the steamer. So what is the steamer? So when we submit a job in the grid, it basically the steamer, the root steamer is basically convert your file in some data members, and that is why you need to put some specific sign to tell root if you want to steam the object or not. For example, this slash colon means it is a transient object, and you means you tell the root that you do not want to stream this object. So the for the means for the simplicity, just remember always whenever you define your input and output object inside your user create output object, means we are going to use this object to initialize it in the user create output object. For that we always need to put this sign, and we need to make it transient for the stream. That means we will tell root that it will not be steamed further when it is going to submit it in the grid. And there is also a particular type of means you can also assign the member partiant. Like if you do not put this exclamatory sign here, then this object will become partiant, and root will do a streaming and make a data object of that. In that case, if you we basically do it when we initialize some global type of variable. For example, in your analysis, if you need some constant eta value or phi value or something value, we generally define it in the public sector. There we basically use this only the double slash, the partiant thing. That means it basically streamed that stream that member and initialize it with a fixed value. So you need to remember that when you define this global constant thing and assigned it as a assigned it for the Partian streaming, then you need to increase your number here. So if you have a more Partian, if you have a members which are allowed for the streaming, so this number is basically depends on that. So if you increase that number, you need to increase it also here. Now, with this information of header files, let's go to the my analysis task. So let's first start with the constructor and destructor. So in the analysis task, we will have two constructor and one destructor. So you can see here in the beginning of the analysis task. So in the beginning of the analysis task, we include our header file that we have already defined in the previous slide, and then defined our class, that is the alley analysis task my task, and put some using namespace std so that you can use the cout thing. Then you need to put this line, that is the class implementation. This is necessary for root, and in the argument you need to put the name of your analysis task, which is the alley analysis task my task. Now in the constructor you can see we in the constructor we basically initialize our input and output object, that is the FAOD, F output list, and F hist PT with some null value. So this is basically the null pointer. And in this bracket, remember that for the first reconstructor, it don't allocate any memory here. So it is basically used for the root input output purpose, and you just need to remain it, keep it as empty. Whereas in case of the second constructor here, it is basically same as the first constructor, but here in the second bracket you just defined your input, you just defined your input and output. So this defining this input of the analysis, what it do basically take, so for example, here in our case the input is some tree in some chain that we will going to take from the AOD root file. So we'll basically take the chain of that event and is created an analysis manager, and in the define output what it will do, it will basically so your output will be the list where you will store your histogram and all those things. So it will basically define the output of your analysis in the form of list and store and configure it with the analysis manager. And for example, you can also define a more number of output. For example, if you want to get output of a tree, you can also define output of a tree. For example, you need to define output, then you need to put two, then tree, and then tree, then the class, tree and class. And for that, you also need to define the your tree in the private sector of your header file. Means it depends how many output you want to get in your output root file. Accordingly to that, you can always define the number of output as many as you can want. Then we have our destructor here. So in the destructor, as I mentioned, that when you create a object and when you delete it, you need a destructor. So you can see here, we basically use this destructor and delete this our output list, that is the f output list, which is defined here with this name you can see here. Now let's go to the main section of the analysis, which is basically essential for us, where we will basically do all the things in your analysis. So first thing is to initialize your histogram in the user create output object. So basically in the output, we will have list, and in this list, we will have the tree, we will have the histogram. So here we have just included the corresponding header file of the list, that is the tlist.h, and corresponding header file of the histogram, that is the thf1f.h. Now let's initialize this list and this histogram. So you have already in your header file, you can see here, you have already created the object by using the t list star and th1f star. So you don't need to uh, reconstruct the object here again. You can just use this name of the object to initialize it. For example, if you want to initialize the list, you just need to put the name and use the new list. Then you need to set the honor k true. It's basically due to some memory stuff that will gives the ownership of the list where you can write your histogram. Then you can define your histogram in this way. And so if you have the histogram that is named at fhpt that you have defined in the header file, then you just use this new thf1f. The first argument is basically the name, and the second argument is the title, and others are the bin number and the range. Then always remember that when you, if you want to get this histogram in the t list as output, you always need to add this histogram in your list. For that, you need to do this add option of the list, this f output list, then add this histogram. In this way, you can define several histogram. You can define 5 6 histogram t profile, how many you want, and you can initialize it here in a similar manner. And you need to assign, you need to create the object, corresponding object in the your thf in your header file. Then you need to apply this post data. So this post data will basically notify your analysis manager and update the output list object. So if, for example, if you want to get two output list, one if one contains the histogram, another contains the tree, then you have to define your two output list here, like define output one list, and then define output two. In the output two, you can put list or histogram or t tree, whatever you want. Then you just need to add the post data, then two, and the name of the object. So in this way, you can initialize how many histogram you want in your output or the other t object. Then now let's go to the analysis section, which is important for our case. So this is basically the this is basically the function user execute, where we basically do our analysis. So this user execute function is basically called for each event, and the manager and the analysis manager will take care of reading the events from the file using some static function known as the input event. Then you have the access of the event, and once this running of your analysis algorithm on a given event is done, then it will go to the next event and do it as long as there is no further event in that chain. So for example, in my header file, I already shown that I have defined a root. I have defined a AOD object, that is the FAOD, and I just call it using the static function here. So what it will do, it will basically get an event called FAOD from your input file, that is the chain, and it will run over it will get it will and then it will run over that event. And there you need to also remember that there is also a particular format of event of data that is called the ESD data. So I will not talk it today. Probably tomorrow I will talk about this ESD data. Now, after getting this event, that is the FAOD, you have to check if the pointer of the event is the properly filled of it is, or it is empty. So if it is empty, you can directly return it. For that, you need to check it. If it is not equal to FAOD, you can return it. Then you can do your you can put a track loop, and you can extract any kind of track variable. So for the track loop, you always need to know how many tracks are there in that given event. For that, you can do it by just getting the get number of tracks from this AOD event. So you will get basically the number of track for that one single AOD event. Then you can loop over this, and in this track you have you can also get the track information from the LEAOD track by using this LEOD track object. So you define the LEOD track object track, and you can get the information by just calling the get using some static function get track, and you can put the number of the track number, that is basically the I, which is I basically goes from 0 to the number of available track in your event. So if you do that, you will basically get the information of the ith track in that event. Then you can put some track selection criteria and check if the track is empty or not. So you can if you can do that by checking that just putting a if there is no by putting this condition. So first condition is basically check if the track is empty or not, and the second condition will apply some basic track selection cut in the AOD, which I will talk in the next days. So here I have just used a particular track selection cut known as the filter bit. And if any of this condition is failed, then it will basically do not continue and it will return. And if it is success, then you can directly call the variable from the tag observe from the track. So you basically in this pointer, you basically store the various observable like pt, eta, phi, and all those things, and px, py, pz. So you can directly call it by using the track then track, and by just calling the pt, and you can fill it in the histogram. And at the end of your track loop, you can directly put this line post data then one and this f output list. So it basically stream the result of the first event in your analysis by the output manager. So this will continue for so this user execute program will be called for each event and continue until there is no event in that input chain of your input file. And then we need to end our analysis task, and we will do it by doing the terminate by using the terminate function. So you just need to call this terminate function, so that will basically end your analysis task. Now we have seen that how to write a simple skeleton of a analysis task using this header file and this .cxs macro. Now let's go to the AddTask macro, where we basically initiate our task, or we basically make a copy of our task and submit it and configure it in the grid. So this is the this is the very basic skeleton of the AddTask macro. So what it does, first it get the analysis manager. So it will basically first create the analysis manager object by this command, ali analysis manager, then star manager, then you get the analysis manager, then you check if the analysis manager have the input, then you will uh, check that if the analysis manager have the input event handler or not. So this event handler basically it will basically handle the means it will basically feed your analysis task the event from the chain. So you can see it here. Put it here. Okay. Okay, maybe I didn't put it here. Okay, so tomorrow I will show it how it does, how it works. And then you need to you have the several step. So first you need to put the file name of you need to put a name of your task, and then you just create the instance of your task by calling the means this is by calling the object of your task, which is basically the ali analysis task my task, which is your class. And in this way you can create a task, and in this task you can add additional condition, like you can add the trigger condition by calling the set collision trigger and all those things. Then you need to add this task in your analysis manager by using the add task. Then you need to also add the input and the output in your analysis manager. So you can do it by using this connect input and connect output, which I have shown here. So in this way your add task macro will complete. So for the moment, if you with this using this 3 macro, you can submit a job in the grid. So the running your task in the you can basically run it in a 3 way. We can run it locally, or we can run it in grid in a test mode, and we can run it also in test mode or full mode, or we can also run it in the Lego train system. Siddharth, do you have time? Then I will go to the submission, job submission thing. Otherwise, I will continue it tomorrow. Siddharth, are you there?
Saurabh, this is Shaikal. Saurabh,
Yeah, yeah.
Siddharth told that he, I think, made you this admin, and so you can continue for some time. He told just now.
Okay. Then I will finish today this how to submit this job. For the submitting of the job, for let's first let's take an example of the local testing. We basically need to use this run analysis macro, so which have different steps. I will explain you now. So first, what you need to do, you need to uh, put so these are basically gives you tells the route from where you need to take the header file of your classes. Then you need to create an analysis manager. Here I have shown that. So these are the basic thing which you always need to put in your analysis task. But I will mainly focus on the things which will basically essential for your analysis. So the first thing is the loading of your analysis task macro. So we have defined our analysis tasks. We in the previous section we have defined our analysis task by using this and create the analysis task, ali analysis task my task.cxx and the corresponding header file. So first you need to load this macro using this G interpreter load macro. So it will basically compile your analysis task. Then you can load it to the AddTask macro using this command. Then you need to give the input of your local testing. For input, if you want to run over some, here we're running over some AOD output file. For that, what you need to do, you just need to download a AOD.root file from your grid and put the name of the AOD.root file here. Then it will basically add the tree of the AOD tree from this AOD root AOD.root in the chain, and then you can start your running locally by using this command manager start analysis local. So the first command is basically gives you the it basically tells you means in which way you want to do the analysis, local or the grid. If you want to do the analysis in grid, you just need to change the name here from local to grid, and here is the input, that is basically the chain of the that is basically the T chain of this AOD.root file. So I have already added some this analysis task AOD this AddTask macro and this run plugin macro in the Indigo page. You can download that, and you can download a AOD.root file from the grid, and you can try to run over it. For that, you just first need to create a token of your alien token. Then you can directly, if you run this macro root minus l run analysis.c, then you will be able to run it locally. There are also several options like submitting job in the grid. I will go to it now. So in order to submit the job in the grid, first you need to configure the alien environment, and you can do it with the several command. I will not go into the details of the command. I will just focus on those commands which is basically needed in our case for the analysis. So first we need to set the library and the source file of the analysis of our analysis task, which is basically you can do it by doing this. First you need to define this analysis handler. Then you can just do it by doing the set additional libs, where you can put the header file and the .cxs file of your analysis task, and then you can do the set analysis source of your uh, analysis task. So basically here you need to put the name of your header file and the .cxs file of your task. Then you need to put the LE physics version in which you want to run your analysis task. So you can do it in this by using this command. So you can set the LE physics version here. So you just need to remember, you just need to change the LE physics version, and the corresponding dependencies like LE root that it will automatically change. Then you need to put the path of the data file over which you want to run your analysis task. For example, here I put the uh, path of a LSC 1502 data, which is basically the LED 5.02 TV data. And then you need to put the pattern of your data. So if you go into this folder LSC 15, you will get several pass 1 and pass 2. Then you will need to go to the pass 1. In the pass 1 you have the AOD folder, and the AOD folder you have the AOD.root file. So the pattern is basically the AOD file. So this is the pattern AOD.root, and you just put this argument to give the proper path of the to the root file. Then you also need to add some prefix like set run prefix 000. So if you go to this folder, you can see there are several run number, but those run number are started with 000. So that means those are the run number for the data. So if you want to run it on some Monte Carlo sample, you just need to remove this 000, because the Monte Carlo run number do not start with 000. Only the data run number start with 000. And then you can add your run number of the data, means in this LSC15O, in this folder, you will get several run number. In those run number, you will get several AOD files. So if you want to run over some particular run number, you just need to put the run number here. And another thing that if you, for example, if you want to run over the several run number, you can also put this command, this line into a for loop, and you can change the run number using some array or something. Or you can also using a string of a run number, where you can define a string of run number. For example, if you have 5 run number 1, 2, 3, 4, 5, you can define a string 1 space 2 space 3 space 4 space 5, and you can directly pass it here. Then it will automatically run over the all the run number. Now here are the another part of this configuration plugin. So I will not go into the details, but there is two things. One, you need to remember, that is that if you want to get the output in the run by run basis, here you can see you have the alien handler set output to run number. You need to make it k true. That in that way it will do your analysis in the run by run basis and store your analysis in the run by run basis. Then if you want to keep the log file for each of the file, you need to keep the log file get true. And another thing is the merging, and you can do the merging via the JDL. In order to do the merging via the JDL, you need to keep this set merge via JDL to get true. And you may have different stages of merging. You can have one stage or two stage depending upon your file number. So you can put it here, the set, how many stage you want, how many merging stage you want, you can put the number here. Now after configuring this alien environment in your, you just need to put those lines in your run, in here in this run analysis. In this way you will just configure your analysis task for the grid analysis. Then you can submit the job in the grid using the analysis handler. For example, if you want to do the grid test, what you need to do, you just need to do the set run mode into the test. Means if you want to the grid test, meaning the grid, you can also do the testing and the full running. If you want to the first if you want to run it in the grid, you need to do the start analysis in grid. And if you do it in the test mode, then you just need to set run mode in the test. And if you want to run your whole analysis in the full mode, that means you want to run over for the whole for the all run number, you can just put it you can change this run mode to the full. And for the merging, you need to add two additional command, that is the set you can see this set run mode and set analysis. You just need to change this set run mode to the terminate mode, and the set analysis will be the grid. So that's it. So I will suggest you to download those macros that I have added in the Indigo page, and try to run those and try to play with those macro. Then from tomorrow, I will show how to implement this various selection card in this analysis skeleton, which are basically we used in our analysis. We put some event selection and track selection card. From tomorrow, I will show how to call them and what are the meaning of those card and how to implement those things. So that's it from my side. So if you have any question, you can ask. So do you all downloaded those file? Hello, can you hear me?
Yes, sir. I have downloaded.
Okay, so you can try to run this run analysis.c. There you can see different means command for running it in the test mode, running it locally or in the grid mode.
Yes, yes.
And you can just change it and write, and you can also try to add some additional histogram in the header file and the .cxs file and try to fill it. For example, you can fill eta or phi or something like that.
Okay, sir. I will try.
Hello,
Yep.
sir. I have a question in slide 13. In slide 13 in class def, you say for practical purpose, people take the argument as one. Yeah, in class def, people take the argument here as one. Actually, sir, I am working with a star experiment, and I have also seen people taking their one, but sometimes they also take zero. So, what is the difference? I mean, why? What is the meaning of one and zero?
Okay, so I have mentioned that the zero is basically disable your input and output for the class. Okay, so basically, if you put it zero, it will also work. It will not means there will be no problem. The problem will come. Uh, the problem will come if you add some member. For example, here these are the public member. If you add some private member and say initialize some variable, say eta equal to 0.5 or something, and then put a double slash. That means what it will do, it will basically stream means the root will basically stream that command, and it will basically initialize this eta equal to 0.5 in all for at the from the beginning. Now, so those is basically known as the Partian streaming, where you allow root to stream your member. Now, if you put another such kind of member, if you put some another member called PT, and if you define it like this way, if you so define PT equal to some 0.15 and then put a double slash, then you will have basically two Partian member. In that case, you need to increase this argument value from 1 to 2. So it
Okay.
if you do not have any kind of Partian member that you allow for streaming in the root, you can 0 or 1, it doesn't matter. But if you change it and if you put it more than 1, then you need to increase this argument number from 1 to 2, 2 to 3, and so on.
Okay. Okay. Thank you, sir.
So if the member is partiant or transient, is basically depends use if you put means if you put this double slash and exclamatory sign, so it's basically transient. Root will not stream it. And if you
Okay,
put
sir.
only the double slash, it will basically partiant. So if you have more than one partition, then you can more than one partition member, then you
But,
change it here.
okay, sir. Okay. Thank you, sir.
Welcome. Okay. Is there any other question? Otherwise, we can stop here and we can start tomorrow with this event and track selection. Okay, so I consider it as that you do not have any other questions. So from tomorrow I will go to this event and track selection card. There I will discuss the physical meaning of those cards and how they implemented all those things. So, okay. Thanks for your attention. Okay, bye.
Bye.